Naming alkenes can be a little tricky at first, but in this video, I'll show you how to decode organic names step by step using a few simple rules. By the end, you'll see that naming organic compounds is more like solving a puzzle than doing hard math. Let's turn confusing names into something you can actually understand. Welcome back to the channel, where our goal at Tadashi Science is to make science simple. Make sure to subscribe so we can continue to help you on your science journey. Before we look at naming alkenes, we first need to know what an alkene is. An alkene is simply an organic molecule that contains at least one double bond between carbon atoms in the molecule. Organic chemistry is carbon-based chemistry and deals with chemical structures built around a carbon backbone. The identifying feature of an alkene is that you have one or more double bonds present between the carbon atoms in the structure. So here you see a few examples of alkenes. The one thing you should notice about all these molecules is that they are made of all carbons and hydrogens, and there are double bonds present in the molecule. Now that you can recognize and identify alkenes, let's look at how to name them. When naming any organic compound, the first thing you need to do is identify the longest carbon chain. So when we name alkenes, we're going to count the longest carbon chain we can find. The longest carbon chain will not always be straight, and it will not always be counted from left to right. So it is important to pay attention to any bends in the molecule, as we are looking for the longest continuous carbon chain. As we count each carbon, we will number the carbons. The number we assign to each carbon will be important, and you will see that as we look at different examples a little bit later in this video. Once we count and label the longest carbon chain, we will then use a specific stem that is related to the number of carbons in the chain. Here's a list of the stems we will use if we had an organic molecule with a carbon chain that contained anywhere from 1 to 10 carbons. As you can see, for 1 carbon, we would use meth. For 2 carbons, we would use eth, and so on, all the way down to 10 carbons, we would use the stem dec. These are the same stems that we use when naming alkanes and all other organic structures, so it is a good idea to memorize these. The other important thing to know when naming alkenes is what suffix should be added to the ending of the stem. There will be a lot of different suffixes to keep track of, but when we name alkenes, it is pretty easy. We will use the suffix -ene or ene. So the stem correlates to the number of carbons in the carbon chain, while the suffix corresponds to the organic class the molecule is a part of. And in the purpose of this video, we are looking at only alkenes, so we will use the suffix ene. So now that you know how to identify alkenes and the correct stem and suffix to use when naming them, let's look at some examples. So in our first example, we'll look at this molecule that has 2 carbons. I will first identify the stem, and I will use the stem eth because I have 2 carbons. It is not as important that we number these carbons because there is only one possible place for the double bond to be. Because I have a double bond between the carbons, I'm then going to add the suffix ene, so this molecule will be named ethene. In our next example, we will look at this structure that has 4 carbons. I'm going to number my carbons from left to right, and I'm doing that because I want to start numbering with the carbon that is closest to the double bond. Because I have 4 carbons, I'm going to use the stem bute. And then we are going to use the suffix -ene because we have a double bond. However, in this structure, the double bond could be in different places, so we need to include a number to determine what carbon the double bond starts at. Because this double bond starts on carbon number 1, I need to add a 1 before the suffix -ene. This will give me a name for this molecule of but-1-ene. In our next example, we will look at this structure that contains 3 carbons but 2 double bonds. So it doesn't really matter how we number these carbons, whether we go left to right or right to left, because the double bonds are between all of the carbons. So I'll just number this from left to right. Once I do this, I'm going to use the stem prop because I have 3 carbons present. Now, we're going to add the suffix -ene because we have 2 double bonds in the structure, but we need to account for the fact that we have 2 double bonds and not 1. So I'm going to add di in front of -ene to note that I have 2 double bonds. And then finally, we need to determine which carbons those double bonds are between, so we would put the numbers 1, 2 in front of di. So the name of this structure would be prop 1,2-diene. In our last example, we will look at a little more complicated structure that not only has a double bond present, but also has a functional group attached to the carbon chain. Again, the first thing we want to do is number our carbons. And I want to number the carbons for the closest carbon to the double bond. So that would be starting here on the first carbon on the left and going from left to right. Now that I know that I have 5 carbons, I will pick the stem pent. I will then need to account for the double bond. So I'll add the suffix "ene" to note that there's a double bond present, but I would need to add the number 2 in front of "ene" to note that the double bond starts on the second carbon. I then need to account for this methyl group attached to my carbon chain. The methyl group is attached to the second carbon, and it is a methyl group, so I would need to add the prefix 2-methyl in front of pent. So the name of this structure would be 2-methyl-pent-2-ene. Now you know how to name alkenes. If you found this video helpful, here's another video to check out. Make sure to like this video and subscribe to our channel as we produce more content to make science simple.